springtime on this February morning. In a courtyard, birds were singing your praise. Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and right now we are going to explore problem solving. Solving problems that can be modeled using quadratic equations. So let the excitement begin. Let's get to it, shall we? Now, in your book, there are a list of steps for problem solving. I don't believe in steps because I think that you should look at a problem and just think about it. Because if you're memorizing steps, you're just wasting brain power and you're not learning to actually solve problems. We don't want people following recipes. We want people thinking. So, the sum of a number and its square is 42. Find the number. If you're ever stuck, though, I will say this. Even if you're not stuck, you should make this statement. Let your favorite variable, n, I'm going to use, be, or represent, or equal, I don't care, represent the number. Whatever it is you are asked to find, let a variable represent it. Then from there, you can express the other parts or the other things within the context of the problem in relation to that variable. So the sum of a number and its square is 42. So n plus its square is equal to 42. Find the number. All right, so here we go. Let's clean this up a bit. I think you can see where this is going. What did I put in the plus 42 is equal to 0. So, except that this should be minus 42. What a loser I am. That would make all the difference because then we can do n plus 7. N minus 6 is equal to 0. So n could equal negative 7 or n could equal 6, right? So I believe we have two solutions, right? Because negative 7 plus 49, that's going to equal 42. Booyah. And 6 plus 36, that also equals 42. So we do indeed have two solutions. All right, next example. A rectangle has length 5 centimeters greater than its width. If it has an area of 84, find the dimensions of the rectangle. So the dimensions, that's what we're being asked to find. So I'm just going to say what's the first thing it says? Length 5 centimeters greater than its width. Well, I'll say let W equal width. And then since it's a rectangle, it helps to draw a picture, right? So this is W, and we want to stay in one variable, otherwise we're not going to be able to solve the equation. The length is 5 centimeters greater than its width, so that's W plus 5. And we know that its area is 84, and the area of a rectangle is equal to length times width. So W times W plus 5 is equal to 84. Let's see, W squared plus 5W, and I'm going to go ahead and subtract the 84, set that equal to 0, and then I'm going to factor beautifully, hopefully. So we're going to have a W, and I think, let's see, 12 times 7 says 8, so that's going to be a plus 12 and a minus 7. 12 times 7 is 84, 12 minus 7 is 5. So from here, we get W equals negative 12, or W equals 7. We immediately cross out the negative 12 because a width certainly can't be negative. So that means that my width is 7 and my length is 7 plus 5 or 12. 7 times 12 is 84. Nice check. How easy was that? And then the last example. Given that BC is 3 meters longer than AB, find the height of the flagpole. Okay, so we'll let let's see, we'll let this be h for height, not hypotenuse. Okay, be careful. So we have let a variable equal the height. Okay, and let's let BC be x from B to C. We'll let B equal to x. Then that means that AB is x minus 3. Okay, so we have a pair of similar triangles, don't we? We have 2 is to x minus 3 as x, or no, I'm sorry, h is to, oh, wait a second. H is equal to x. Look at these markings. I'm so stupid. Okay, so that's x. So as x, because this segment is equal to this segment, as x is to the entire length here, which would be x minus 3 plus x. Okay, so let's simplify this before we cross multiply. So that's going to be x over 2x minus 3. So then we would get x times x minus 3 is equal to 2 times 2x minus 3. Cleaning it up, x squared minus 3x equals 4x minus 6. Clean it up some more. X squared minus 7x plus 6 is equal to 0. And we're going to factor like it's 1999 and get x, and then minus 6 minus 1 equal to 0. So x could be equal to 6, or x could be equal to 1. And you always, always, always need to be checking your solutions. X cannot be equal to 1 because if you look here, 1 minus 3 is a negative number, and you cannot have a negative 3. So our answer is x equals 6, and you could replace x and check all that out to be sure of your answer. All right. That is all I have. Let's check it on out and see. Ooh, you're not supposed. Okay. See how Donna Lewis is doing. Hope you enjoyed it. I know I did. I am. Oh.